and I intend getting a great deal more from you than $700 a month and 2 weeks paid vacation.
Who are you? The new number 2. Who is number 1?
I just don't have any idea what you're talking about.
It's weird.
Sorry, Mad Moose. They're not in the system yet. I probably have the Python DVDs somewhere, but I don't know, like they also have a laugh track, and I'm not sure if like the laugh track would kind of work with like the weird kind of clipped random sentences. But yeah. Okay, I think we're good. I think we've got everything we need. Alright. Probably should have had a strong tea before I came on, but that's okay. We can make do. Make do best we can. Let's Oh. Alright. let's switch over to desktop mode. Hey, hi. Yeah, welcome to another game dev stream, where in this instance, yeah, we're creating an adventure game for DOS from scratch, and yeah, so we've actually gotten pretty far. We've gotten pretty far. So last week we were working quite a bit on just like the menu system and the GUI, and let me show you where we are with that at this point. It's actually quite good. If I can just get to the right spot. Actually, no, I should be in here. DOSBox. Yeah, okay. So here we are. Got our game. We've got our inventory bar down the bottom. I'll just pick up an item. Now we've got this button on the right-hand side, which opens the menu. So we see that it'll retract the little inventory panel down the bottom. You've got some choices here. You can hit like resume to just go back to what you were doing. If you have something attached to the cursor and then you click the game menu, it'll put it back before you do that. And we also have, I don't have the save and load ones done yet. That's also going to be like another kind of difficult technical challenge because it would involve, yeah. So I've decided that we probably need to have a save and load format for the engine, and I think I know how I'll do it, but yeah, that's probably going to be like one of the last things that I do, because the game is quite short. You technically don't need these two, but it does make the menu look nicer. But options, we've got a second screen here, which has working sliders. So thank you, ScumVM, which I kind of ganked some of the mathematics for like moving the little, but you can like click on it and it will snap to the right spot. You can animate something that's happening on the right-hand side here. I don't have these sliders actually wired up to the things that they profess to be about. So that, like, the plan would be to obviously attach the text speed slider up to the actual speed at which dialogue and stuff moves around the game. Likewise for this, and this is gonna be tied into the EGA dithering feature, which I worked on, but have not. Again, I have not wired this button up to anything yet, but yeah, eventually we'd be able to pick between VGA, which is what you see here, EGA with 16 colors, and maybe CGA. But of course, yeah, but that'll just be in terms of palette choices to begin with. It's not impossible to actually write graphics drivers for EGA and CGA, which would then actually, I don't know, use the hardware at the time. But we've got a little ways to go before we get there, and I'll get into that in just a second. So the main thing though is that I've just been testing here in DOSBox, and DOSBox, you'll see here, it just has like the word max 100% cycles, which is kind of what it does when you run a protected mode. It'll just run as quickly as possible, which most of the time that's kind of the thing that you want, because yeah, because if you're running in like an extender like DOS4GW, which implements like the DOS protected mode interface, I think it's called, technically what you're meant to do is run it as fast as possible, but then also yield. Like basically, whenever you're not doing anything, there's a function you can call called DPMI yield, which essentially says, well, it tells the DOS protected mode thing, just sleep until you hit the next hardware interrupt, which could either be, I don't know, usually it's the timer. So like here we've rigged the timer to run like at 1,000 hertz. So it'll be basically like when you hit a yield instruction, put the processor to sleep until you reach that. And that's kind of important both for not red lighting the CPU and also for running the DOS, like running this game inside Windows. That's like a big part of that, because with Windows, like, I don't know, this, DOS doesn't know what a thread is. So you can't just like go, oh, I'll run this in a separate thread and leave it to like the kernel to magically make multitasking happen. No, you have to yield back to the DPMI extender, which in turn will yield back to Windows, which then means you can do like I don't know, Windows event handling, like key, and there's also some kind of like crazy stuff going on in terms of like requesting the hardware. So yeah, have not even begun to contemplate how we're gonna deal with stuff like what's it called? Sound card. That's it. Yeah, I've not even like given any thought to like how we're gonna do the sound card stuff. But we have here. So what I thought that we might kind of do to start with is so I know that like a lot of Twitch streamers, they take pride in their streaming rigs and like their fancy kind of capture devices and their capture device change. So I feel I should probably like show off my fancy capture chain now. It involves, very technical. It involves taking this webcam, rotating it 90 degrees, and pointing it at this laptop from 1997, running Windows 98. It is old enough to have a Intel Inside Pentium MMX. It has a CD drive and a floppy drive, but more importantly, at the back, it has one USB 1.1 port, which is what I've been using to like copy code onto here. But if I run the game, actually, what am I doing? I should be like switching to big camera mode. There. So we can see the game does run on this old hardware, but it's not very fast. In fact, like you can see like how much it's lagging like crazy. And if I move down to the inventory bar, which is basically like tied to the frame update, like 1 pixel per frame update, we can see it's dog slow, and that's not ideal. But we can actually play the game. We can walk around. We can pick up stuff. Also, good to see that like the animation speed is not in fact coupled to the display update speed. So like walking is like the correct speed. Text being played back is the correct speed. But still, like this ain't good. This could be a lot better, I think. So what I think we'll do is, oh, that's right, we've got the quit screen. Oh, the quit screen, which I hadn't actually wired up to anything, so that's okay. We'll quit out of here. Control Q. Continue. Control Q. Okay, that's right. Keyboard input gets eaten up when yeah, I forgot that keyboard input gets eaten up when you when you're in the menu mode, the game goes into pause mode. So none of the actual game event loops happen in the background. It's just a special loop for updating the GUI and running callbacks from the GUI. So anyway, let's go back here. So actually no. There's one other thing we should probably quickly do. So we do have a debug log that is running. It is too large for Notepad to open. Would you like to use WordPad to read this file? God, yes, I would. I'd love to do that. And I saw this quickly before the stream. Like, it's loading all the assets fine. It's creating a bunch of text. That's all good. It's loading the palette. This is where it kind of starts getting a bit hairy. So you may be aware that for the so for ease of like developing in DOSBox, I added in a special feature which turns COM4 into a debug, like a telnet port that you can then like connect to as a shell, or with a pretend serial cable in DOSBox, which is all well and good. But as you can see here, like I haven't removed that here, and yet it's getting a whole bunch of the letter Y or the letter Y with umlaut, which I'm sure is like some significant character in. Oh, and it's got like, yeah, okay. I think this may be just like FF over and over and over again, but more importantly, what I want to check is if we go into settings, control panel, I think there may actually be some real hardware on this which uses COM4. I just don't know what it is. So there we go. We'll go to device manager. We'll go to, is it the modem? I think we might just have to like try me, you know. Oh, here we go. Ports, COM and LPT. So we have communications port 1, we have ECP printer port, we have virtual infrared COM port, which doesn't have a driver designation. We have virtual infrared LPT port. Because yeah, on the back of this machine, we can see that it has a single USB 1.1 port, a black square which is for infrared transmission, and then we have just DB, like a 9-pin serial, a printer port, and I think a VGA port on the far side. So that's the ports that you get. So let me just go back to streaming mode. Okay, so what I think we're going to have to do is we're going to have to, oh, that's right, there was one other thing, and that was the frame rate. So there's like a frame rate at the very bottom of the log. I'll just read it from here. But essentially, I think what's happening is because like COM4 is getting a bunch of junk traffic from somewhere, that means that the, what's it called? Every time the debug port gets some incoming data, it will hang for up to like 50 milliseconds waiting for more. So I think that might be why it's kind of like partly why it's kind of lagging so much, because it's doing that and it's also like trying to write to the log file, which are kind of naturally very slow operations. So what I think we'll do, we'll just quickly try and like turn off the debug port and have another shot. Have another shot copying it off. So just it is also a laptop which has a this is a Toshiba Satellite 320 CDS complete with nipple mouse. So that's kind of what I've been using to drive. But I just gotta stop. Any second now. There we go. I'm always a little paranoid at like doing anything with USB while on the stream because I've had like bad experiences where with a USB webcam will not enjoy that as well. But I think we're good. I think I've just plugged it into a different bus, so we should be all right. Okay, so first things first, we've got to turn off the debug port. Ideally, we should. So yeah, like another thing which I should really do is I should expose it to Lua, which then means that it can be changed in like the game script if required. Yeah. At some point, I was so like I've got a plan to have support for reading an INI file, which will do things like configure the debug port and like the default video driver. Essentially, like anything that you change in that that options screen should get written out to the options file or to the INI file. But that's that's all we can do. Hey Marianne 10918. How's it going? We're just in the middle of we are just in the middle of troubleshooting on a laptop from 1997 with this, you know, very complicated turn the camera to the right capture technology. Okay, so main.c? Yeah, main.c. Okay, so main.c is pretty basic. This is like, I guess, the first bit of the code that runs. It'll load in the driver, which currently just exists for MS-DOS, and we've got this. Yeah, so loads in all of these like stubs, which are like MS-DOS, you know, basically like use the DOS timer, use the DOS keyboard, use the DOS mouse. And then this one here, which is use the DOS serial port. And I'm pretty sure that I've hard-coded it in there. I've not made it configurable yet. So like if I search for COM4, which I'm pretty sure is, yeah, I've just hard-coded it. That's not great. Okay. So yeah, DOS.c is like the kind of messy, I don't know, like all of the platform, you know, like all of the assembly language ish kind of, or you know, bare metal crap is in here. So some of it involves like hooking the, you know, the ports and the interrupts that are on the DOS PC. And in this particular case, the COM port, yeah, that uses this output port to get all of the what's it called? No, sorry. It sets up the COM port by poking a bunch of registers through the port system and then reading like a single byte or reading a status line bit or something from that port. So I think we might have to, and yeah, like the problem is here, I've just hard coded it to be like port COM4, which isn't ideal. I think let's open up this website, which I recall had all of the good information about how to program ancient serial junk, because oh yeah, like another thing I could do is like, I'm pretty sure that I have a serial, I may have like a DB8 to USB serial cable in my horrible cable box in the back. So I could rummage through there and then try and attach the laptop to the computer and then do the, I don't know, that seems too ambitious. At this point I think we'll settle for kind of what we need to do to change it. So it's 2E8, was it? 2E8? Oh, okay. Base address used. Oh, okay. So this page doesn't actually explain what the base address is. It's got some other dingus. Port list. That's right. Okay. So serial. It's 2E8. Where did I get 2E8 from? How about just like all the ports lists? HTML edition? Hang on, can we browse by? Because yeah, this is kind of the Bible of every single interrupt and port and stuff for MS-DOS, unfortunately, there's a ton. There's way too freaking many. And there was a, hang on, RBIL ports list. I swear there was a better one, like one which actually... no, that isn't it. Because yeah, there's a few different kind of... Originally, this was just a bunch of text files, and then some people did some stuff to put it up on the internet. Rough Bronze interrupt list in HTML. Maybe it's going to be huge, but that's okay. Oh wait, no. Delry's got it. Okay, we'll use that. I'm pretty sure the Delry one is good. I think the Delry one was good. Oh no. What's happening? Why is the browser doing that? I swear, this computer sometimes just feels like it's just on the edge of... Oh. Why is it dumping core? We're still streaming, right? We better still be streaming. Okay, no, good, we're still streaming. Oh no, okay, no, the browser just crashed. The browser just crashed and we're now at 53. 53 CPUs worth of load. That's fine. Nothing wrong with that. Hang on, I'll close DOSBox. There we go. That should free up a little bit more. So yeah, this number roughly equivalent, you know, is equivalent to how screwed I am and how choppy the stream is going to be. Hopefully that should bring it back down. Yeah, it's coming back down. Okay, so let me open again the sacrificial web browser. I need to close some tabs. maybe that's the lesson I should take away from this. Okay, whatever. That page didn't work. That's DOS port list. Doesn't have to be RBIL. Just oh god, alright. And of course, port is like a really rough word to search for. Is it just in the docs? Interrupt handlers, port. RBIL serial. I'll just search for the serial port. That would have been the smart thing to do for me. 2E8H. E8 02E8. Thank Christ. Okay, this will. Okay, this better be it. This better be it. It better not have crashed. It crashed. Sweet. Okay, there we go. What is going on with systemd core dump? What is dumping core? Core dump CTL. Okay, so it's just WebKit. It's just WebKit that's been shanking me. It's been doing a little seg fault. That's okay. Okay, if I try and open up the nice web page directly, will that load without seg faulting? No. No, this web page this web page doesn't seem to be working. Oh my god. Little segfault is a tree. Yeah, exactly, Mad Moose. Okay. I'll use the unsafe web browser. There, here we go. Oh, look at all the information that we got. Okay, so we've got port 02E8 2EF, serial port same as 2F8. Oh, right, okay. So yeah, sometimes like port numbers are mirrored or recycled. So I guess that like the canonical name for it is maybe 2F8 or something. So we go reserved. COM4. Okay, no, 2F8 is COM2. Alright, let's start writing these down, so before we forget. So we'll say define COM4 port X2F8. Sorry, COM2 port. Define, I guess 3E8 is the... Okay, that's COM3. And then working backwards, 3F8 must be COM1. Right, so... And how's the driver currently set up? Okay, so serial init does all of this. Okay, it will try and... Okay, I think what we need... We're gonna have to, like, fix this init script so that we can selectively turn this on and off. So, like, if we look at what we did for the sound card... okay, sound card is also hard-coded, which... might be an issue, but hopefully it's not. Do any of these have... Oh, whatever. Whatever, we can go static. uint16t serial port base 0. Okay, and that will be our we will use that in lieu of COM4 port. So I'll go uint16. Yeah. There is also the question of, like, how do we... Like, I don't know. I'm unsure about whether or not we should push information through this init method. That could be a big problem. Or it could be an issue when we move away from DOS. Like, obviously, like, not every platform is going to have a single number which can define what the port is going to be. That's a very DOS specific thing. So for now, I think what we will do is just hard code it. We'll hard code it in here, and then basically, if this is set, we'll then assume that the serial driver is working. Otherwise, we'll just make it a no-op. And then that way we can just quickly turn it off and check to see if the crappy laptop is good. Okay, so serial port base equals COM4 port. Okay, fix me. Make this programmable. And then now we gotta go COM4 port. Actually, hang on, no. How many of these have got? Oh god, I've got so many. I'll just temporarily ruin these. And there we go. Replace COM4 port with serial port base. And then we can fix these two. And then we'll basically just go if serial port base return false. If serial if actually so all we're doing is we're just going to every one of these serial related methods and putting in a little kind of short circuit so that if we haven't turned on serial, then do nothing. Just do nothing. It's fine. It's normal. Okay, and that's already, yeah. It's already good, and then all we need to do here is comment that out. So I'll take all of this. Why is it sleeping? Hang on. I'm gonna turn like, because I think it's got the 3D pipes screensaver. We want to see that. So we'll go display, appearance. Actually, what am I doing? Hang on. Settings. Oh no, we're under power, I think. Power management. Okay, when it's plugged in, turn off monitor after just like 2 hours. Okay, that's in. All right. Will this be any quicker? Oh, it's still kind of, yeah. It's still lagging like crazy. Wait, hang on. It ran like at full speed for like a second. I wonder how much of this is down to Windows, or like running it alongside Windows. I mean, in theory, it should be properly yielding, but clearly it's not. Like, look, it did it again. It did it again. What is going on? Hang on. Is it just when I hold down the control key, it runs at full speed? When I don't push the control key, it lags like crazy. This makes me think that maybe it's like it's probably the yield. It's probably the DPMI yield, because like I'm guessing that like holding down a key would trigger a lot more interrupts. But I don't understand, like, okay. But it's, I mean, okay. So the good news is that so the good news is the computer is in fact fast enough to run this. It is just something bad going on with my timer code. Oh, it's annoying that it happens when I push Control Q, because what I really want to see is like the timing at the bottom, except yeah, when you hold down Control, that counts as a repeated key. I think like 14 is normal. Let me check. Okay, no, yeah, so DOSBox manages to do the frames in like 9 milliseconds, though I'm not sure how much of that is down to like the display controller running at a different speed on the laptop, because like 14 isn't too bad. 14 isn't too bad. Okay. So how do we debug this then? How do we debug this? Alright. So there are a couple of things we can try. One of the things we could try is we could try just loading the game in DOS without Windows and see if that impacts. Well, we could see if it impacts a few things. Like, it should be playing back. I'm pretty sure it should be playing back music, because I modded it to use the AdLib driver. So that clearly isn't working. But yeah, if we ran it in DOS, then we wouldn't have Windows constantly grubbing around waiting for input, which would then, I guess, would rule out if it's Windows' fault or if it's my fault. It's probably going to be my fault, but it's probably going to be my fault, but we can absolutely do that. Alright, give me... Okay, so... make a folder for it. I've forgotten how nice. I've forgotten how nice this keyboard is. Like, look at that key travel. Look at that. It's so, yeah. Compared to just having what, like 1 or 2 millimeters. This is luxury. You get a whole. It's like almost 5 mil. 5 mil of key depression. It's great. Okay, so that's all in there. We can then shut down the PC and restart in DOS mode. I don't, yeah, it should just struggle on even if it can't find the AdLib card, so that's okay. So restart in DOS mode. Okay, it's got the mouse driver, which is good. Okay. The disk activity light is on, but doesn't seem to be going anywhere. What's going on here? Have I somehow made a DOS game that only runs in Windows? That's kind of impressive. Alright. Well, hang on. Let's try that again, but this time with the other kind of DOS mode. Oh, it's locked up. Okay. Command prompt. I think these should be the same. I think this should be the same as the other one. Oh wait, no, it doesn't load the drivers, so technically it's worse. But it's okay. Let's see. No, it just hangs forever before actually doing anything. Let's say before doing anything. Maybe, yeah, maybe it's like the audio driver that it's getting stuck at. Yeah. I think what we might have to do, we might have to go back and mod yeah, we might have to go back and mod the DOS drivers to just kind of write to the log file to say when they've accomplished something, like starting things up, because it's not clear like which part of the yeah. I mean, like, it hasn't obviously reached the game at all. It's hanging somewhere in the drivers, and we can tell that because the screen is still the same. It hasn't got up to like the point where it's changed the video mode. So it must be hanging early. So, all right, switch back.
Song. Press that note to pick that song.
Thank you very much for the follow, Ghost Matter. Good to have you. Equals 03 says that little laptop is a thing of beauty. It is. No. I've owned this machine for a very long time. Loved it to bits, and it's You know, the screen I mean, it's doing pretty well. Like, I've replaced the hard drive with a compact flash card, but yeah, it still has a network card. It's still got a modem. CD drive and the floppy drive still work. Battery dead. I haven't gotten around to like buying another battery, but yes. I've had yes. What was I going to say? Yes, I've had this for many years. It's really good. And I'm glad that I'm able to put it back to good use in testing this fool's errand of a project. Okay. So what I can tell is that we haven't reached here yet. We haven't reached the video in it. Because we can see here that like the very first thing it will do is it will change to mode 13H, and then do a bunch of register crap to make what's it called? Essentially, you know, usually all you need to do is this, which is like say, you know, tell DOS, I would like mode 13H please, which gives you, you know, a raster graphics with 256 colors at 320 by 200. Because I'm a masochist, I I learned that if you do a bunch of like, you know, nasty things to the VGA registers, you can basically use all of the memory, and you then don't have to worry about like single buffering, because like so this is how you turn on double buffering, which is essentially you say, I would like 2 entire copies of the screen please, and then while you're busy rendering one, I can then write the other one to the screen and vice versa. It is quite a pain in the ass, because you have to turn off this thing called chain 4 mode, which then means every pixel is like, I don't know, you have to like slice every pixel on the screen into 4 chunks, or what do you call it? You basically like write the first out of every 4, then the second out of every 4, and the third out of every 4, and the fourth out of every 4. And you know, eventually, your code to write crap to the screen starts to look like this, which is just insane. It should be just as simple as I have a graphic and I just want to copy it left to right, but for various optimization reasons, you gotta do it in order, which then means like, I don't know, first keeping your graphic in like, you know, slices of 4, and then writing the slices in the right order. Anyway, doesn't matter. That's all irrelevant, because we're not even getting there. We're not even getting up to this instruction here. So it must be dying earlier on. Is my takeaway. And what have we got? We've got something which sets up the logging system, something which sets up the event system, the timer init code, which we've already kind of hobbled to not do anything. Oh no, sorry, the timer code sets up the interrupt for what's it called, sorry, it changes the default timer in DOS from, it's like 60, you know, it's like 16 point something, some weird thing, to what is it? 18.2. There we go. So by default, in DOS, you can only like poll for something 18.2 times a second, which is not very many times. That's actually kind of bad. But we have a bunch of quasi assembly here. Well, not quasi assembly, like just crap which touches the registers, which then increases this to 1,000 times a second, which is actually, you know, useful for a game. So that's what this one does. This one here is similar to the timer one, except it sets up the PC speaker. And then this one down here sets up the OPL, which is the Yamaha FM synthesis chip used for music playback. So, alright, let's timer init. I think we're gonna have to go here and... Okay, so we'll... Okay, so we've got this. Oh, okay, so we actually have some, so we've already got some log statements here for the Yamaha detection. Because, yeah, like, I'm pretty sure, yeah, I wrote this so that it will just try and detect if there is an OPL3. And if there is, it'll have a whinge. Sorry, if there isn't, it'll have a whinge and then just kind of return. Otherwise, it'll set this flag to say, yes, we've got an OPL3 card here. So I think that's probably enough. So maybe just put one at the top and say, oh yeah, and I got to put in a new line, because for reasons. So we'll do that. Change. I think this detection method I nicked from Commander Keen, so it should be good. That's pretty resilient. This I gotta add in some new lines too. We gotta add... That's fine. Oh yeah, the PC speaker. That's what we're gonna fix. Okay, oh no, PC speaker in it literally does nothing because it just relies on the timer. so it's got to be one of these two. Maybe the event code. The other option is it could be the file system, like the reading stuff from the disk, which is giving it an issue. I don't know why it would be. I mean, it's DJGPP. Like, why? There's nothing special. It's just writing a file to a disk. But yeah, another option is we can turn off. If we disable this instruction, then we can disable like writes to the disk. But for now, I think we'll keep them in there. Okay, event init just sets up a okay, it just zeroes out an array. That's fine. Yeah, okay. So that'll reboot while I copy the damn thing to the God, that's loud. Oh good, starting Windows, okay.
Whatever it is, recovery will be quick.
Hey, crushing ceiling. Yeah. Hang on. Wait. If I do this, will it get the... Oh, interesting. Okay, so if I turn brightness all the way up... No, my camera just can't get a beat on what... It was working really good a second ago. I don't know why... Okay, it's slightly more visible if I turn the ring light on. So we'll keep it like that for now, but... Okay, so if we go... Okay. My computer, removable disk. Let me take this. Actually, more importantly, was there anything in the log to start with? Wait, what? I mean, it looks like it got as far as running the game script, but that can't be right. Why didn't it change the graphics? I mean, where did it end? Okay, it ended at creating the text. Okay, maybe what I should do is next time I try it, I should try just doing Control Q, because I'm pretty sure that the keyboard handler is always going to be grabbed. Oh, maybe it's the mouse. No. That's a DOS BIOS thing. You don't need a friggin' drive for the mouse. God, that's so weird. So weird. But I'll just copy this to here. And we'll just double check that it works. Oh god. What happened there? Oh no. Okay, hang on. I'll just turn off the... Uh-oh. So you can see how there's like kind of a... You can kind of read, you can kind of read words on the screen. Well, hello. This program is performed a legal operation will be terminated. Quit all programs and restart your computer. Try to execute an invalid instruct. Oh, god damn it. Hang on. No. It's gonna start that again. What? And that's what? This time it worked. Oh no. Come on. Come on. You gotta fail it. Fail one more time, please. Oh, what I wanted to do was see like the little kind of crash message that was behind, because you can actually use that. That's actually that's quite good. It's quite good to have that. And also the fact that it was kind of like, what you could see there for a little bit was that because we were in Unchained graphics mode, you could make out words, but they were kind of spaced out like a old-timey dot matrix printer, because that's how I don't know, when you draw text to the screen, that is still technically a bitmap in DOS. It's just you know, it uses the same memory, it's just arranged in a different way. So the fact that you could make stuff out was kind of interesting. But okay, we've still got the issue where quite slow unless I hold down a key, in which case it seems to be running at mostly full speed. So we'll quit. Just double check this log. And yeah, like at the good speed it's running at like 14, yeah, what's it called, 14 milliseconds per frame, which is not too bad. And yeah, we've got replacing DOS timer interrupt, DOS timer hot patched, detecting Yamaha OPL chip, found Yamaha OPL 3. That's interesting. So, and I say that's interesting because, hang on. How come we can't hear any sound? It's got two speakers. It's got two speakers and they've been like, hang on, can we play entertainment, Windows Media Player? Surely we've got a mid. It's Windows 98, I think, so we should have a mid. Media? Okay, well we can... Oh no. Why, has the amp blown in it, maybe? Because, like, I swear that I was, like, playing sounds on this before. Okay. 1 second. What do we got here? We got... Interesting, okay. So when I turn up the volume control, I can hear like more noise. So the amplifier is definitely increasing, but nothing is coming out the other end, which makes me think maybe it's a... Okay, no. That's why. It's because the Windows mixer is not correct. So, okay. So we want full CD audio, full... Oh, we don't have line in, so we'll just say full MIDI and full wave. And now... Okay, that's good. And that should also mean that we should get like audio when we play, when we run the game, because I've put like the test music file in there. Oh, here we go. Okay, we got a crash. That's good. Okay. Okay, we can do some debugging now. All right. So you see this message here. You see like all of this junk here. So these numbers are the key. This is telling us like exactly where in the program things have gone south. So what we're going to do is we're going to, or rather I am going to, cut back to the desktop here and start looking up a few of these numbers. So I think PT base is the, okay, so where is to line? Okay, yep, we're using address to line, which is from the DOS compiler, which is kind of important. Address to line EPT base. And then we'll try one of these addresses. 026A34. Okay, so it's crashing somewhere in Lua, which is not great. What's the lowest one? We've got 808B. Oh, there we go. Okay, so this is in code that I wrote. So not, it's a much stronger contender for a screw up. Where was it? 599. Yep, 599. So this was in... Okay, so it was trying to... So it's trying to read main.lua. So something happened when it was trying to kind of process main.lua, which is kind of a big deal. That's kind of where all the game code is in, and it didn't like it. So I think okay, so somewhere in Lua crashed because of that. So I think, okay, we'll go back to tracing, like, let's pick the very top one. 79D85. Okay, that's somewhere in DOS, that doesn't count. 4265C. Right in the guts of Lua. Not... What are we doing? 418. Oh. Oh, right, okay, so this is opening another file. So yeah, like the main.lua part, like, hang on, I'll show you how this works. So we have main.lua, and all it does is it has these three commands, and it's basically do, you know, run this file, and run this file, and then one of those three instructions seems to have not gone so well. Seems to really cratered. But I don't okay, fine. Why? I mean, okay, the do file I understand. But why did it crash there? Why did it crash there? Okay, we might have to go even lower Might have to go even lower than that. So another thing we can do, object dump, hang on, source development DOGPP, senenv, object dump. So we can, so if we go object dump, capital S, pt base.exe. So here we go. Here's the entire assembly language output of the program, and we just need to scroll to the bit that caused the screw up, which is 79D85. Oh wait, no, that's the traceback handler. Okay, I understand. Okay, so yeah, the very top number on this list is inside the handler DJGPP, which prints this wonderful message here. So it must be, yeah, okay, so 4265C must have been the screw up point. So 4265C. And okay, so that was calling Lua-L load file X. I don't understand why that would be an exception. Okay. The Windows error message is wrong. That is not correct. Okay. Fine, so I mean Lua-L load file X is there. Why is it having a problem with that? 4265 and C. It's adding oh wait, okay. Oh no. So like I'm reasonably sure that it's here. This is where it's having a bad time. But because I can't see, because like if we look at ESP, yeah, ESP is a pointer. You can add 10 to that easy. That's also, I don't think that you can crash the program just by adding 10 to, or, you know, adding hex 10 to something. It's got to be this call here. I just don't understand what's going on. Like, is it some kind of I don't know, maybe it's a Windows thing? Maybe because we're running this protected mode application in Windows and it just sometimes doesn't work. I don't know. I'm drawing a blank. I have no idea how we're meant to figure out more from that. It just, yeah, it just decided not to work. And of course, if I like run it again, chances are, yeah, it's fine. It's fine that time. Okay. We'll have one more go in DOS and see if we get some more logging information. So switch. Ah, that's different. Okay, so it switched graphics mode, but then it just kind of hung. That's a. I guess that lines up with like the disk thing that we were seeing before, where it looked. So if I push Control Q now, like that. I don't know. Because yeah, if there is a DOS keyboard handler, it should have picked up Control Q and used that to quit, but it's not clear if it did. Okay. But the little disk light is lit up, which implies that it is writing or trying to do something with the log file to the disk. You know what? Yeah, I'm starting to think it might be the log file that's screwing everything up. Because yeah, in Windows that would all be, there would be no DOS involvement. Like that would all be replaced with Windows code. Whereas in DOS, that would be using the DOS file system driver, which may be different. But so if we look at the log here, yeah, it tries to load a bunch of pictures into memory, gets like reasonably far, like it replaces the DOS timer, it finds the OPL3 chip, does like a bunch of stuff, but then for whatever reason it has no trouble like it just kind of hangs when it reaches here. Okay, that's really friggin' strange. Alright. Oh boy. Alright. So, knowing what we know. Okay. So, that crash is interesting. It is interesting, but it does seem to be sporadic, so I'm going to chalk that just entirely down to some kind of weird crap that is happening when Windows tries to shim in DOS mode. Fun, but not really much I can do about it. But the thing not starting, that seems more insidious. That seems like it might be more of a problem. It would be nice to know how much memory is being consumed. I mean, I just want to quickly check. Because I'm wondering if, like, maybe when we're in Windows, there's virtual memory or something which it gets to use that it doesn't have in DOS mode. I don't think we're using, like, 32 meg of it. We are loading a lot of bitmaps, but that shouldn't add up to that much, I would have thought. So, if you go, like, accessories, system tools, resource meter. What resource do we get? We just get resources. Doesn't say what units they're in. And why would it? Why would it say that? Okay, system monitor maybe? System tools. System monitor. Okay, that's processor usage. Do we have memory usage? Processor usage. Okay, maybe there isn't a way of checking. Ugh, that's okay. How about, okay, Windows 98 check memory usage. There's got to be a way. Okay, memory management in Windows 98. Okay, memory management in Windows 98 and Windows Millennium Edition is dramatically improved over what exists in Windows 95. It is so much improved that for nearly everyone, nearly all the time, the best recommendations on how to best use it is let Windows handle it. Yeah, I want Windows to handle it. I just don't trust it. Okay, vcache, whatever, swap file so large. Wait, do I have Norton System Doctor on this machine? I've got Norton. I think this machine came with Norton Antivirus. So do I have like Norton System Doctor? That's something I didn't consider. Oh no, it's just Norton Antivirus. God damn it. Toshiba applications? No, it's just registering crap. No, it doesn't seem like we have that. Windows 98. Memory usage. Memory monitor. It could well be that there just isn't a way of viewing this on Windows 98. Okay, anyone know a good task like, okay. Oh my god. What is this browser is so bad. Honestly, this browser is just the worst. Okay, after boot, Windows slowly eats up memory. How about if I just try the old Reddit? Will that crash the browser? God. Yeah, I need a better temp browser than this. Okay. Alright, here we go. Anyone know of a good task manager-like program for Windows 98 that shows memory usage and CPU usage? Don't know if System Internals Process Explorer works. Oh, wait, no, there's an old version of Process Explorer. Great. It's exactly what we need. Can I view the old apps website in this, my soon to becoming my most hated web browser? Well, it's not crashing yet. Oh god. Do I have another browser that isn't... Okay. Do I have Midori? No, I don't have Midori. Because, yeah, where we're kind of left, right, is it would be good if we knew how much memory it was taking up, because that would explain why it might just hang in the middle of doing something. Because I thought this machine actually had, like, a fair amount of RAM. I thought it had, like, 32 meg? How many meg? How many meg does this have? Yeah, it's got 32 whole megabytes of RAM. Oh, okay. Of course, oldapps.com is gone. Okay. Plan B. Get rid of the old tab, open up a new uncursed tab. But where does this leave us? Okay, so it's mostly working in Windows. The only issue is that well, yeah, the issue is down to the timer, or what's it called? This guy, DPMI yield. So this is currently our idle loop, and I'm guessing DPMI yield on real hardware is a lot lazier, which I don't understand, because it should be being woken up, you know, by the clock. Okay, but we'll grab this ancient version of Process Explorer. Oh god, but it's... Oh no, when it's not gonna work, is it? Oh wait, no? No, it is gonna work. Maybe? Maybe it's gonna work. Whoa. What if I just try and download this in the command line? That's probably not going to work because it's behind Cloudflare and the upstream website's cooked. Right. Oh, here we go. Let's visit ftp.braindrainland.nu and download this totally legit copy. There we go. Ugh, go away. Okay, so got this here. Run media, unzip, downloads, procex. There we go. So we'll see how much info we can get out of this. So if we crack this open. So what columns we got? We got process name, we got PID, we got CPU usage, description, company name. Okay. So it doesn't give you memory usage. I mean, there's DLL information. Look. Okay. Well, did not like opening that help file. Had a nasty turn when I opened that help file. Yeah, God. Sometimes you just forget about how kind of unstable Windows 95 and Windows 98 was compared to today. I mean, today it fails just in more kind of like frustrating, more obsequious ways, whereas now you just get a little BSOD, every now and then. Okay, well, I'm starting to think that you don't get memory monitoring in Windows 95, which is kind of sad. I mean, that seems insane. Surely there must be a way. Then I refuse to believe there isn't a way that you can't tell. How about like DOS memory usage or DJGPP get memory usage? Let me guess. I can't load this page too. Nope, it's a core dump. God, this... Okay. I'm sick of this browser. I'm sick of it. Okay, alright. Okay, do we even use sysidle anymore? I think this might have been the old way that I did it. Let me just... let's... Okay. I don't think we use sysidle anymore. I think this is how I was originally doing it, and then I changed my mind. It's now all handled in script has quit, I think, which is... has quit. Oh no, okay, so we'll do this forever effectively. So wait, okay. So how does this work? Okay, so we get the number of ticks, which we're just using it to keep track of the frame times, so that's irrelevant. It must be in script exec. Script exec. Okay, so script exec runs all the threads. We then do a keyboard update and a mouse update. Which polls whatever is in the keyboard buffer. That's same with the mouse, I think. Yeah, we just poll the mouse registers. Okay. Okay. After we've done all that, then we go to script events. God, come on. Help us out here. Yeah. So script events, then script render, which is a similar thing. So like nothing in here is yielding. Maybe it must be in this video flip, which is where we put the yield. Yeah. Okay. So maybe this isn't... It must be this, right? Because it works fine when we kind of introduce a bunch more interrupts. And yeah, okay, VJ is VBlank just polls this status, CRT mode and stats register through this port. Okay, at which point we disable all interrupts and enable all interrupts while doing this stuff. Tell me more about DPMI yield. Are you going to load this page? Yes, you are. Okay, thank God. Okay, DPMI yield calls function 1680H of the interrupt 2FH, which tells the task manager in a multitasking environment that the calling program doesn't need the rest of its time slice. The task manager will then preempt the calling program and switch to another task that is ready to run This function should be called in busy wait loops, like when a program waits for user input via the keyboard after it finds the keyboard buffer empty to enhance overall performance in a multitasking environment. Okay. I assumed that this was called every time that the interrupt for the timer got called, but maybe that isn't the case. Maybe it just kind of waits for even longer. Slow? Timer interrupt. And like the timer, I mean, we're definitely patching the timer to be 1000 hertz because otherwise the rest of the game wouldn't run at the correct speed. We could, as a kind of like very basic hack, we could try replacing this with just a boring sleep and seeing that if it... Press key. Oh god. Okay. Alright, do I really not have another web browser that I could just use? Actually, what am I saying? Of course I've got another web browser. I've got I've got the terrible Google one. We could just use that. Oh, except... Oh no, there we go. There. That's got to be better than just like seg faulting on every other page. God damn it, really? Okay. Okay. 6.7 using sleep in DOSBox. Okay, that's just a seg fault problem. That's not what we want. Okay, waiting in DOS using DJGPP. Alternatives to BusyWait. I recently wrote a little cursors game, and all it needs to work is a time mechanism and some cursors. The idea to try and build it for DOS comes naturally. Timing is already between this and this. Okay. And that's using uClock, which is just a manual busy wait. Obvious question, okay, it's like browsing with docs that came across DPMI yield. If you're running in a multitasking environment, there'll already be a DPMI server provided by the operating system. And of course, in that case, we want to give up our time slice while waiting instead of trying to use HLT. Yep. Okay, and then this just detects. Oh, right. Oh, right. Okay. Does DPMI yield not work in pure DOS? Is that the mistake that I've made? Is that why like DOS is screwing up like at that particular point? That would make so much sense actually. That would make a ton of sense. Yeah. If the call isn't supported by the environment like when running on plain DOS. Like when okay. Alright. Okay. So that solves that mystery. So it doesn't return anything, but at the same time it doesn't do anything, which then means that it'll just busy loop, I suppose. Okay, it's possible to do even better by checking all the available methods and picking the best one. I found a DOS idle call that could be considered as well. Oh my god, alright, that's one of those. If yield is supported, use this. If idle is supported, use this. Otherwise, in ring 0, use plain halt instructions. Oh, okay, and this CWS DPR 0 is ring 0. Do I use the ring 0 one? No, I use CWSD stub. So we can't... Really? Okay. Possible to do even better by checking... Okay. Right. Okay, so... Alright. I don't particularly want to use the halt call because that doesn't seem to be... Well, it would mean that we need to use the like the ring 0 CWS DPR thing. Not sure I really want to do that. Also has like... I'm not sure if that has like a bad repercussion for just running in plain Windows, but this DOS okay, and this is interrupt 28. DOS idle interrupt. Here we go, okay. This interrupt is invoked each time one of the DOS character input functions loops while waiting for input. Since the DOS call is in progress, even though DOS is actually idle during such input waits, hooking this function is necessary to allow TSR to perform DOS calls while the forward... Okay, what the hell? Alright. It says IO functions. Don't know though if that's... Alright, well we know... Okay, so... How many places have I used DPMI yield? I've used a couple places there and a bunch of places here. Alright, so we're gonna have to make a new... Okay, I think we'll put it as part of the timer code just to make it easy because we need to have the timer set. We'll also go checking for yield mode. And then we'll just do what that person said, which is set error node to 0. Then we'll do a dpmi yield if error node okay, so how does this thing work then? So this is checking for the DOS idle interrupt, and then how does it actually use it? So we've got none idle yield halt. Right. The DOS idle call is documented return immediately if no other program is ready to run. Therefore, do one halt if we can. Okay, right, so this is... Okay, so this is dpmi yield. Does not block the program, it just gives up the remainder of the time slice. Should not be used by Windows-specific programs. When called very often without intermediate screen output under Windows Strip X, the VM will go into an idle state and will not receive the next slice for 8 seconds it elapsed. Oh, jeez. Alright. Says this call is supported by MS Windows 3 Plus, DOS 5 Plus, DPMI 1 Plus, but I don't know. Maybe I'm assuming that this doesn't exist, but well, at least okay. I'll go if use dpmi yield. Okay, there is this thing here which is like timer sleep. Okay, we do that to, is that really the only place we use it? Just, I thought that we used it somewhere else, but maybe we have to add one of these in. Oh, God, alright. Okay, it's part of the API, but nowhere else in the code do we do a sleep. I don't know, maybe. Okay. Alright, sys yield wait 1, sorry, no, dp my yield wait 1, keyboard, oh, what's it called, right. Actually, do I have any? Okay, let's look at like another DOS program. Like, do I have Rise of the Triad? I thought I had rot somewhere. Just anything. Anything which uses DPMI yield. I'll settle for that. Actually, hang on. Easier option, which is just check all of GitHub. We'll let that percolate through, but hang on. Code, please. Right. Okay, Megazoogs. Good. Okay. DPMI yield. Interesting. Okay, so they just did, okay. So this source code does a delay. And then normally it'll just kind of wait. How does this work? Okay, so okay, plus timer ticks. Oh, okay, because yeah, it's a, okay. So there must be some other interrupt which is updating timer ticks, and then it just yields while it's waiting to do that. Otherwise, it does nothing. It does, okay, it doesn't seem to be, and like yieldable is just checking, okay, just checking that. So, which is what we should be doing. Okay, then yeah, that seems pretty pedestrian. Seems pretty vanilla. Any other games? Any other DOS games in here? Oh, okay. Turrican just has one dumped in the music playback thing. Okay. Okay. For Linux, I just do a usleep 10. That's sleep for 10 microseconds. For DJTP, I call to this DPMI yield function. Note that you could use usleep for both DOS and Linux, but in this case, you should sleep for more than 18.2 milliseconds to let DJGPP sleep really release the C. Okay. Weird. Alright. I think it's easier to call this. So like at the end of the day, we're waiting for this V blank signal. which in turn is getting the CRT mode and status register. Alright, it doesn't feel like we've meaningfully done anything different. And it's not like DPMI yield will screw everything up if you call it. It just sets error no if it isn't there. Okay, so we'll just... The other thing we could just do is we could just turn off DPMI yield altogether, which will break multitasking on Windows, but it will it'll establish whether or not that's the thing which is holding up screen updates. So I think for experiment's sake, let's do that. Let's just never set DPMI yield. Oh, wait, what? Why did... Oh, jeez, okay. Why is DOSBox crashing now? How about if... Wait, what? Okay. Okay, here we go. This is like the non-cursed version. I'm running it on like perfectly working fine. Okay, no, it's crashing for some other different reason. Possibly because my system is just having the worst time imaginable. Oh, it's probably because of all those browser sessions that died. I don't have proof that it's that, but hang on. No, it's just if yes, it's the web browser. Okay. So here we go. So game runs fine in DOSBox just at 100% CPU because there's no sleep. Yep, and okay, interesting. So the frame times seem a bit high, but I'm not sure if that's just down to... Because it could be that maybe like the method that we're doing for checking to see if the graphics are ready to be updated is bad. And we should find a better way of doing that. But anyway, that's got no yielding going on now, so we'll see if that improves things. Oops. Oh, okay. Yeah, it's... I think... Oh, that's right, it crashed before, didn't it? So we're gonna do this. Oh, run scan disk. Made a mistake. Wait. Don't know why it's hanging around on 85%. Like it's a compact flash card. It's a freaking compact flash card that it is running on. It should be way faster than any hard drive known to science. And yet it is just hanging there. Oh no, it's gone up to 86. Perhaps, I don't know, perhaps it's doing some kind of last mile thing. I don't know. We'll just we'll leave that there. We'll leave that there going through its thing. Okay. Or I could just put I could push exit. I could push exit. In fact, it's very tempting to push exit. You know, just a little corruption, just a little hard drive corruption. Okay. That's another question. Like, yeah, just get where'd the mouse go? Where'd the mouse? Hang on, I should be looking at this through here. Oh, there it is, okay. Computer. Okay, it started it. Ah, alright, it's not the yield instruction. So even with the yield instruction turned off, it's still slow as molasses until I like hold down a keyboard key. Also, okay, so yeah, the mouse does nothing, but keyboard does seem to do something. That is interesting. That was okay. So what is it about the keyboard interrupt which kind of makes it not bad? So what does it do? It... Okay, we don't even... Oh wait, do we? Okay, we replace the protected mode keyboard handler. And we replace that with keyboard handler new. Int 9h prot. Okay, so this is the handler. And all it does is... Yeah, okay. So just call, yeah, it calls this every time there's a key event, but... Hey, Cube runs. Yeah, DOS is terrifying. The more I learn, the more I am just kind of permanently in a state of shock that that it runs, that stuff runs on it. That, like, I don't know, a whole bunch of people at Microsoft managed to kind of somehow balance Windows on top of it, like a giant pyramid full of champagne glasses, just kind of very precariously balanced on the edge of a table. That's what it all feels like. It feels like it come crashing down any minute. And now we're at the rubber, where the rubber meets the road. We're trying to figure out why in God's name you can't just get the damn, or rather, like, we're trying to determine which part of this morass is responsible for just making it feel real laggy. Okay, so another thing we could try. Another cheeky thing we could try. Instead of I mean, at the moment, the reason why I think that it's kind of... Okay. New theory. This method here, VGA flip, we're basically forcing the damn... What it's meant to do, right, is it's meant to do all of the work. It's then meant to run into here and then basically wait until we hit the vertical blanking interval, which basically is basically the VGA graphics card's way of saying, hey, I'm about to redraw the screen, at which point it'll then do some memory dingus, which then switches buffers, switches to, like, buffer copy 2. Now, it relies on, it basically just kind of, like, sits in a loop, permanently, like, asking the VGA card, is it ready yet? Is it ready yet? Is it ready yet? So potentially what could be happening is that maybe this is just kind of hanging around way longer than it has to. So if I were to replace this with just a fixed wait, say, like, don't know, 5 milliseconds. Like, I don't know. The downside is, like, if we just say update the screen every 5 milliseconds, it should still work. There'll probably be some, like, screen tearing because it's not updating at exactly the right time, but that will then identify what we're doing here as part of the problem. So I think, yeah, okay, I think we'll do that. So we'll go is vblank, and instead of doing it the nice way, we will just actually, what was the... Okay, timer sleep. So we'll just replace this with timer sleep. And we'll say 5 milliseconds. Because the frame rate I think in VGA is meant to be 70 frames per second, which would be how many milliseconds? 1000 divided by 72 or whatever? 13, okay, fine. But 5 should feel responsive. And even if it doesn't make it up to 5, doesn't matter. Oh, you know, even if it like lags for longer than 5 milliseconds while it's actually doing all the work, that's fine. The important thing is it should appear not terrible, which is where we are now. So we'll comment both of these guys out. And we'll put in one of these. And then back into here, we'll go up here and turn back on DPMR yield because we know that it's good. Oh cock! Ah, I forgot that I undid all my changes, didn't I? Stash, apply. Oh god! All right. Git stash apply. Then we go back into here and okay. Now comment this out. Comment this out and PT sys timer sleep 5 milliseconds. Okay. Yep, and then okay. So it runs even without yielding. We're just telling it to wait for 5 milliseconds. So yoink. Run media thing. Unmount that. Actually, no. One thing I wanted to double check, because it should be playing back music. It should be playing back the beautiful unfinished piece of music in here. Yeah. So I've set up rad load and rad play, and it's in the assets folder. Yep. So what gives? Why no playback? Maybe that'll be the next issue once we figure out what the timing problem is. Also, the strangest thing, I recall trying an earlier build out and it didn't have the laggy issue. So why is this kind of cropped up now? But then again, that build could have been tried before I redid the graphics driver to be like unchained. So potentially it could be that. Don't know. Don't freaking know. Okay. Let's see if this lags. Okay. Answer, nowhere near as much. But it did crash. Okay. So, this is... Oh, this doesn't look good. Okay. Page fault. Alright. Address to line... Oh wait, no, I'm in the wrong spot. Address to line... 69B60. B60. fseek. Okay, so some of the file system code. Line 80. Wait, alright. Okay. I wonder how much of this is just down to, like, I'm running it off the USB, which is potentially not good. Yeah, 8090. Yeah, right. I think that, like, because removable disk F is just, like, not quite a proper disk drive. I'll copy to drive C. I'll do the kind thing. So we copy to drive C. Yep. Don't know why there's a Moronash folder inside Moronash, but that's okay. Okay, so here we go. On drive C. I mean, that almost feels good. We can pick up the items, we can open up the menu. And if I... Oh, it crashed again. Crashed again at the same spot. Another page fault. Object dump with source code, PGBase. 69B60. Let's move from ESP to ECX. All right. GG. Hardware, okay, page fault. Okay, when CWS DPMI detects your handler accesses memory that is not locked. Okay, but that's if it says page fault in RMCB. This can happen if your program installs a callback for some real mode service like the mouse callback. Okay, like that's a very real risk. Like part of like what makes DOS extra precarious is that all of the actual code which needs to interact with the hardware has to be done in 16-bit mode. DJGPP is like a 32-bit, DOS extender. And so part of what you need to do in all of this driver code is make sure that everything is just locked down like crazy. Because essentially, yeah, like the best way to describe it is that everything in the code like all of this stuff here, it technically is virtual memory. Or rather, like all the stuff that's in like DOS 32-bit mode is virtual memory and can be moved at any time. And the way to work around that is, for 16-bit code, you have to create a special handler which then locks all of the memory, which is to say, like, prevents it from being, like, paged out to disk. So I think that what's going on, right? In the engine, like, memory is constantly being used and freed. Especially, like, when text gets shown up on the screen, like, that's an example. Like, it'll create, like, a brand new buffer to, like, render the text to, and then, that can then be cleared by, like, the Lua garbage collector and stuff like that. Which is fine. The issue, though, is that if in any of the driver code we're operating on memory that isn't locked, then that's bad news for us. That means that we can like hit the wrong page of memory and hit a fault. So I think, I may have actually made it worse. I may have made it worse. So like, you can see here, like the timer code will lock everything between this prot lock and this function here. Well, it locks this. Wait a second. Have I screwed this up? Have I made a mistake? Because, I mean, this code is locked, but all of this stuff up here, I don't think is locked. Which could be a problem. Let's double check. Let's double check Go32 DPMI lock code. Locks the given region of code starting at lock address for lock size bytes. Lock address is a regular pointer in your program, such as the address for function. And yeah, like this is like a perfect example of something that like DOSBox will be fine with, because I'm pretty sure DOSBox doesn't like change memory paging, because it doesn't need to, because it's already virtual at the lower level. Windows, on the other hand, it absolutely will change the memory paging. Go32 DPMI lock code. Lock my handler. Minus my handler. Oh wait, no. Okay, that's lock code. There's a separate one for locking data, I think. Yeah, we've got lock code and we've got lock data. Because it's 16-bit code, alright, because it has to be interoperable with 16-bit code, there's a difference, I think, between the code which is in the code segment and the data which is in the data segment, and therefore they have two different types of locking thing. So do we have an example of DPMI lock data? Oh, here we go. Okay, so the time. Okay, I get it. Yeah, all right. So this may be in jeopardy actually. So do we check? Okay, so let's move. I mean, like, okay. Yeah, okay, so we're only in trouble if this gets called, like, inside an interrupt. But we may as well just lock it. There's no harm in locking it. Oh wait, maybe the audio driver? I mean, that could explain why it kind of crashed there, because yeah, one thing we had to do was lock all of this stuff. Okay, so we have this code. All right, the shutdown code does call the timer. The file loading code calls the timer. Or no, sorry, yeah. Yeah, so like this loading code is fine. It then creates a timer using our programmable timer mechanism. And then, god damn, why is this so hard? What was the other address? It was 69B60 and 8809. Oh, okay. So it wasn't related to Rad Player Shutdown. It was just before Rad Player Shutdown. That's a problem. Oh, it was okay. So it was trying to print these last frame times. So we'll just try that again. For the most part, it seems fine. So okay, we'll call that a red herring for now. But all right, well, the timer is clearly working. Yeah, it's just this V blank wait. This V blank wait is just doing us dirty. Ah, crap. Okay, HTML edition, ports list, video. $3DA? Okay. It's almost what I want, but not quite. Browse the index. V for vertical blank. God, alright. Ports list. God, why is this? Oh my god. Expansion bus buses. RVIL 3DA. Oh. I swear I was looking in reserved. Whatever. Doesn't matter. Okay. CRT modem status registers. We are looking at bit 3, I think, of the... Oh no, sorry. Yeah, bit 3. That's for CGA. VGA vertical retrace. Okay. Syncing, okay, yeah. No, that's a different kind of V-syncing. GameDev.net. Okay. I need to wait for the vertical display retrace so I know when to blip my back buffer to the video memory. Here's a code fragment I found somewhere of a thing. Literally just check if this bit is set. No, continue waiting, which is honest to God what we're doing. Windows 3DA V retrace slow. DPMI 3DA retrace. Okay. Import BO3DA. Okay, so like this is an example of a game where it just, yeah, it does exactly the same thing that we're doing except sloppier. Like how, okay. There must be something fundamental that we're missing about this. Like, let's read the wording exactly. Okay, bit fills for CGA status register 3 in vertical retrace. So that would imply that like when it is finished drawing to the screen and it is moving we're in the vertical blanking interval. That's my understanding of what that is. Blanking interval. DAH. Okay. Ooh, hard for him. Okay. god, alright. Here we go, here's a scruffy old PDF. 3DA. Input status register 1. Tell me everything. Okay, the address for this read when set to 1, this bit indicates a vertical retrace interval. Okay, right. This bit can be programmed through the vertical retrace end register to generate an interrupt at the start of a vertical retrace. I vaguely recall reading somewhere that this is nonsense, like the, what do you call it? IBM have kind of messed this up in such a way that, you know, realistically in DOS you can't do this, you can only poll for it. When set to 1, this bit indicates a horizontal or vertical retrace. Okay. This bit is the real-time status of the inverted display enable signal. Programs have used this status bit to restrict screen updates. The inactive... Okay. The video subsystem is designed to eliminate the software... Okay, whatever. And we're just kind of checking to see that it's only bit 3 that is on. And the code specifically is to wait until the screen is not v-blanking and then flip the page. So maybe, I mean, maybe this arrangement here is a bit cooked. But yeah, I don't understand. I don't understand why holding down a key on the keyboard would suddenly make this better. DOS screen update v-blank. Is there a diagram? No, there isn't. Okay. Wait, alright. I'm right now developing a game in MS-DOS for C++, and the card is currently... I need to test if the VGA card is currently in the vertical blanking interval. Is there a memory address I can just read? How do I check for this? Okay, you can write... Oh, alright. So this is... Back when I learned about it, it was a bit of a gamble as not all VGA handled this in the same way. I stick to the bit settings that I learned at the time. Okay, we want to avoid doing this if possible because this sounds sketchy. This sounds sketchy and like just a magnet for crashing. Not sure I want to do this. Enable the interrupt on the pick. Is that just the timer? I thought we did that. Hang on. OA. Oh no, the timer is interrupt 8. Oh, here we go. Hardly any software uses the vertical retrace interrupt because it's unfortunately not reliably implemented across VGA cards. Some clone cards don't implement it, some do, some require a jumper to enable it. Some chips have the pin available, but it's not connected to anything. Yeah, okay. Yeah, this is the one that I read. Okay. DOS vertical retrace enter. It could just be that the timing that we have on this is just, I mean, I don't know. I don't know. I don't know. So like, this is the thinking that we had, right? The thinking that we had when we put this code together initially was we basically wait until, you know, basically wait until the electron beam like got all the way to the bottom of the screen, at which point it would, hang on, is it that way around? So yeah, basically it would wait until we'd hit the bottom of the screen, and then, okay, once it's in that vertical blanking interval, was it the other way around? Okay, because really, what do we want to happen? We want the page to have finished. Sorry, we want v blank to have finished happening. Oh, sorry, we want to be in v blank, if that makes sense. Like maybe I've just got these two reversed. Like, oh god. But yeah, like the thinking, right, is that as soon as we're no longer drawing anything on the screen, we should then try and change the registers to flip the screen around. Yeah, change the registers to flip the screen around, then wait until we, you know, the screen is in blitting mode again. I think. I mean, there's one easy way to check. If I just like if I just invert these so that we wait until we're out of v blank, and then oh no. So yeah. So technically, this is. So wait till we're in v blank. Okay, so that's it. Okay, that's flipped it around. I'm not sure if that'll. In theory, that shouldn't change very much. Oh god damn it. Okay, and we'll test this out. We'll test this out here. So it seems fine, and we've got like nice low frame times. So now okay. There you go. Now you can see the the fun screensaver. God, yeah, like back in 1997, like being able to have a 3D screensaver was really freaking cool. Okay. I need a better shortcut for like just copying the exe over. Weird lag, but okay. Okay. No. No, that didn't fix it. It must just be, yeah, maybe, dare I say, is the VGA card in this laptop just not good? Or like just, I don't know. Is the VGA chipset just like holding out and not returning like accurate VSync information? Because that's a possibility, and that could be bad. That could be... it's not ideal. It's not ideal. But I just... yeah. Okay, here's a thought. Here's the thought. There's got to be some example out there on that big wide internet of ours of a demo, like a DOS demo that uses that VBlank. I remember seeing one. So DOS double buffering VBlank. Because we have double buffering. Yeah, port V 3DAH is bit 3 signaling vertical sync when the bit when the bit is high, the vertical sync period is ongoing and frame buffer data can be updated easily. Okay, have your code wait for the bit to become low, and then wait for it to become high, and then update the frame buffer. And our code at the moment... yeah, okay. Now that we've changed it, it now waits for it to go low, and then waits for it to go high. Not many virtual machine environments properly emulate VGA vertical sync at this level. Okay. Yeah. Double buffering, refresh, resync. Double buffering and refresh. Oh wait, no, that's not talking about DOS. Come back. Polling for VSync doesn't work. This is it. This is the one. Okay. Okay. I'm using a virtual machine. The timing of your game should not rely on VSync. Yeah, I know it shouldn't. My code run outside the VSync, but I still need to update the screen without flashing. You won't get far using emulators. You should also get... Okay, fine. Fine, guy. Hang on. Okay. Let's have a look at the Rise the Triad source code. Okay. Vid. Okay, so there's like mem to screen. Yeah, right, which is doing the same kind of draw stuff. Field bar, T-bar. I think, okay, update screen. Alright, so this is the screen updater. Right to all planes. Alright, let's get the source code. It's good enough to if it's good enough for Tom Hall, it's good enough for me. So we've got a bunch of methods here to update the screen. Or sorry, a bunch of calls to VW update screen. I think that may be the flip method. 3DA. Oh, here we go. Status register 1. Oh, okay. No, that's just setting the overscan border, which cool trick and something that I need to add to the engine, but that's not the same as. I guess maybe they don't. I guess maybe they don't poll for VSync, and probably for good reason. Okay. Flip page. Is this the trick? I mean, we have double buffering. So in theory, it shouldn't be the end of the world if we just flip the page without actually checking to see if we're in vertical redraw, but Okay, so yeah, right. Alright, so this engine kind of looks like it's just flipping the page as quickly as it can, which is fine. Nothing wrong with that. DOS, is it worth vsync? Does this game even sleep at all? DPMI yield. Oh, right, okay. I swear there was like a copy of the rot source code which used like DJ GPP stuff, but maybe I'm misremembering. Okay. Anyway, this scrawny old nasty old code. Oh, here we go. This doesn't use DPMR yield. Oh no, that just sets the border. God, alright. Sets an attribute, palette border register does not vsync. Only mention of vsync is in the file saying does not vsync, but thank you whoever wrote that. Oh, here we go. Wait VBL. Okay, so this is the wait code in the Commander Keen engine. Okay, and by default it does do that. I don't know. There's examples of and yeah, in this case it's waiting for it to be clear, and then it's it's waiting for it to be set, then it's waiting for it to be cleared. has a number attached to it. Oh, okay, it's this loop instruction, so it's basically wait for this many vertical blanking intervals before going to the next one. Note, wait VBL can miss the VBL signal several times in a row when music signal is active, which can cause VW wait VBL to wait a lot longer. Okay. The given amount of VBLs. Therefore, the fading routines in here will wait for timer ticks instead of waiting for a VBL. This might be a clue. Because I don't... So, in my mind, it should, like... Updating the sound card shouldn't take that long. However, we do run that in an interrupt, which does technically rob time from the vertical blanking interval. So let's try that. Let's try turning off the sound card. I probably should have done that to begin with. I probably should have just gone through and like progressively turned off everything that wasn't nailed down. But that's okay. We might be able to get closure. So here we are. Starting off here. Hell, we can probably just not run the music. Just not run the music driver. Okay. Let's open up a notepad session and then drag main.lua into it. Turn off the music driver. Nah, still inexplicably slow unless you're holding down a key. Frigging okay. Okay, I think I mean, we can log. We could do something similar like we've got here, which is essentially it would be nice if we could log to a file how long the vertical blanking interval takes. The issue is that, you know, it happens like 70 times a second. And that's the territory where if you just try and write to a file 70 times a second, you will slow things down by the act of writing to the file. So what we've done here for just measuring the frame times is have just an in-memory buffer, and then like as soon as we quit the program, we dump those numbers to the file. Which mostly works, except the act of quitting the game involves holding down. We can just fix the menu. We can fix the menu. So like the issue is that like if we push down Control Q for like the final few frames before quitting, everything will be fine because I'm holding down a key on the keyboard. But the mouse doesn't fix anything. So we can just change it so that we can quit with the menu and we don't have to touch the keyboard at all. Assuming I can find the right file. Yeah, okay. I'll just go pt quit. Okay, so that's one part. One part is that we gotta make this so that we can quit. The second part is that we need to this sample stuff here. How do we do this? So we'll disable this, we'll disable both those things. Wait a goddamn second. It just occurred to me, this doesn't measure the time that the flip operation takes. It's only measuring the time that the frames takes, so we'll call. So let's duplicate this. I'll go flips. Okay, alright, alright. Let me... Okay. So in theory, if we run this, it's still going to be bad graphics. It's still going to be really slow. However, we should see a bunch of time being sunk in flipping as opposed to rendering the frames. But we'll see. We'll see what happens. So that's built. I'm going to mount this. Copy. Copy that there, and copy all the scripts. Okay. So still woeful, but we should now be able to quit the game. Good. And then if we look at the logs, yeah, okay. So the frame calculation time is about 16 milliseconds. Kind of high, but yeah, here's what it is. And the flip times are like all freaking 166 milliseconds. That seems like a nice round number. So 1000 divided by 166. 6 times, it's 6 frames per second. Almost exactly. With like one exception. But yeah, why 6? Why 6 frames? Like that seems very, I mean, anyway, and if we run this again, but like this time, holding down some keys before we quit, and we open up the logs. Yeah, the flip time suddenly becomes like 3 milliseconds wait. I mean, I would understand I would understand if it was like because we were spending so much time in an interrupt, like a drivery thing, that we'd miss the V blank, but kind of feels like the computer isn't giving any. Doesn't feel like it's giving any V blank, except when the keyboard is being pulled, and that's insane. That's I don't know. It doesn't make any sense. I feel like I'm taking crazy pills. Anyway. Okay, I think we've done a fair share of esoteric DOS troubleshooting. I think that I might have to like hit up some people in the DOS community to see, firstly, is it worth doing VSync at all? And secondly, is this just something kind of weird that I'm missing? But yeah. Anyway, that's kind of, I think we're going to stop there. The thing I'm going to try and do a little bit more painting, I think, because I've been yeah. I still have not started. I mean, I've got like a layout for room 3 out of 3. I have not started it. I still need to finish room 2. So let's try and get room 2. Let's try and get room 2. God, it's like 3 and a bit hours already. Okay, I spent way too long on this. I should have given up earlier, but it just felt like I was like that close. But you know what? Part of knowing your limitations is knowing when to basically say, this is way too hard. This is way too hard, and I need an expert to sort it out. Okay. So this is room 2 of the game, which is about 70-ish% complete. We just need to fill in the background here. Maybe in a little bit more detail. Oh, and we got to add in a wall over there. But yeah, we've got these barrels, we've got these nicely labeled pipes, we've got this air filtration unit, and got this reactor. So you know what, yeah, okay. We'll put the break timer on because I'm not sure how much we'll use it, but at the very least we'll get some background music in so I can properly get concentrated. What am I saying? Okay. Brain is leaking out my ears after looking at too much DOS stuff. This is a problem. I don't it's not good. Anyway, so yeah, as is tradition when doing a bit of painting so that my brain doesn't completely shut down, we're going to do 15 minutes of this puzzle game, 20th Century Food Court, and then 15 minutes of drawing. Okay. We'll see if my brain is completely, like, 20th Century Food Court is crazy hard, so I don't know how effective I'm going to be, just kind of jumping straight back into it. Okay. Oh god. I remember none of this. Okay, I think we might have to make a new... Okay. Gonna start the timer. We'll do it with a new, clean machine, because I remember nothing about how it was set up before. Okay. What do we got? we've got... Oh, that's right. This is the one with big chip. This is the one where you have to make a big chip in a cup. Okay, so we have all of these combinations of things. We've got plain... Okay, you can either make a burger that's plain or with cheese, an orange or purple drink, and either like a big chip in a cup or an onion in an onion ring in a cup. And yes, so 20th century food court, you have to generate a series of like conveyor belts and robotics to put together these meal orders, and the layout kind of looks a lot like the Doper Eurorack system, if you're aware of modular synths. The trouble is that it's very, you have to kind of like, the complexity kind of like ramps up very quick, very fast. So I think what we're gonna have to do is we're gonna have to do, for a problem like this, we're gonna need to kind of split it into small, easy to digest chunks. And which ones we got? We've got, oh that's right, and yeah, the other trick with the drink is that you also have to put a little lid on the drink. And what dispensers we've got? We've got this freezer which can dispense meat, potato, like giant chip or onion. We've got this one here that can dispense either a bun or some cheese. And this one here which can either dispense a cup or a lid. So maybe we should just focus on filling the... And yeah, it's also made difficult by the fact that like the chip also needs a cup. So you can't just create a closed loop which only dispenses a drink. It would need to dispense maybe a drink and an empty cup, and then your machine will have to like know to pick up cup 2. Anyhow, drink-wise, you need to dispense the same drink twice. Okay. Okay, starting off. Put a big conveyor belt with a stacker. Okay. So we're gonna have a nice big start bus. There we go. So we've wired a counter to the stacker, which means that there needs to be 3 things that arrive for the stacker arm to put on it, and then it will release the tray. So that's that. Oh, and yeah, once you run out of space here, you're screwed. You can't add any more. So, here's what I'm thinking. We've got the cup dispenser here. The cup and the lid dispenser, sorry. We could very easily just create...
There he is. And here to tell us all about Bournemouth is the presenter of BBC's computer programme, and a man who loves computers so much, he even changed his name to Computer Jones.
Yeah, we need Computer Jones here right now. Maybe Computer Jones would know why the DOS vertical blanking thing is just deciding to shank me like it did. Anyway, so let's wire output A to cup, output B to lid, output C to left, I guess, and then output D to through. So the pattern that we would need for dispensing a cup. Oh yeah, God, and we would need we'd need a separate thing for the soda, which I had not considered. But for now, we'll just pretend. So, dispense a cup. Wait 2 time units, then kick it through. And then at the same time dispense a cup and then send it through to the left. Actually no, the point, it's one of those. Dispense that, nah, okay. We'll see how that looks. Dispenses a cup, waits 2 time units. Pushes that off there. Oh, okay. Good, alright. Okay, and the 2 drink choices we have are orange and purple. Now, okay. So here's a very common problem in 20th century food court. You have some information that you want to keep around. In this case, like whether it's going to be an orange drink or whether it's going to be a purple drink. And there's limited ways you can do that. You can have a counter which you can then like offset by 1 and then use the 0 to figure out if it's one or the other, but it's not ideal. Because yeah, and like a counter will only ever tell you if it's like 0 or positive. Anything that's so yeah, that's one way. Another way is that you could have a scanner that is sitting down here next to this dispenser, and it reads the little barcode that's on the tray, and then you basically get one of these, except it's not an impulse. It's just constant. Another option would be that we just have 2 sequences, but okay, 2 sequences would cost 10 grand. 2 counters would cost... Oh, yeah, okay. Let's try it with 2 counters. Not ideal, but whatever. So basically, it would then be inverted. So you can see orange is on the left, purple's on the right. I wonder. You could technically achieve the same thing with one of these. So if we did +1 was orange, and then we just had another +1 here that was purple. And then we had -1, which was the start signal. Okay, so that's... Okay, that's positive for orange. And then if you change that to purple, then it's 0. Okay. Okay, so we've got that. And then... Oh, no. So yeah, like that. The problem is like once we've done that, then we've got to the bit where it's basically like, okay, but then we need like more gates, like an AND gate to ensure that we're only like clicking on orange or purple when we need to. At which point it's like, okay, that's, you know, we've already like run out of our budget. We may as well just have another sequencer just for dispensing drinks. And that's okay. We can. Oh god, wait, hang on. No, maybe we need this and a sequencer. Because like the budget, right? We will already need two No, okay. Alright, so... So the other thing we could do is we could have another sequencer that's wired up to the same start signal. And we just do that. And then we still have like this complete run of... We've got 2 outputs and then this complete run of the board to do other things. So we can just use that later. In the meantime, I'll just move this clutter over here. Okay, so that's our drink. Not quite. We're gonna need... Sorry, I forgot. We need another stacker. We need a stacker here. Specifically to stack the drink. There we go. Because it's only one item, we can just wire it to itself. That's... okay, so that's good. Then we got all this other crap. Okay. Next item of business, big chip. We gotta take the freezer unit here. And then purchase a deep fryer. How long do we have to cook them? Oh, okay, we just have to cook them Oh, but then there's a whole bun cutting exercise. Now I remember. Okay. But anyway, that was 15 minutes. So let's switch back. Do another 15. But this time drawing. Okay. So, okay, we've started the job of coloring in over here. Which layer's got the stupid blue line in it? Ah, it's this one. It's this one here. So yeah, we've got single point perspective up here, which is what all these red lines are. They're kind of like denoting the skew of the image. Where did filter casing? Okay, let's just start coloring it. Didn't use the right color. Hang on. Alright, so kind of clashes a bit with the placement of this though. Yeah, if we're... I mean, we can get around it. We can just say that this is, like, at an angle. But we just got to be careful that it's not too suspicious. I guess the other option is we can move it, like move the giant pipe.